Hello. So, in this video, we are going to be talking about sort of the general sort of umbrella of mathematical reasoning. Sort of what is it, and give an example. So, mathematical reasoning, this is really the process of sort of converting information into the mathematical language so that we can then apply deductive logic and sort of figure out what we want. So, the sort of layman version of this, right, is the idea of going from like colloquial language to mathematical language so that we can then sort of mathematically or logically work through a problem to get to whatever answer we're after. So by way of example, I figured I would actually give one that actually happened to me. So my mother is a professional potter. She's an artist for many decades now, and she's building a wooden kiln. And wood kilns are very complicated things because wood does not sort of burn hot enough to actually be used in a kiln normally. So there's all kinds of fluid dynamics and stuff involved. You'd think that's where I come in. Not so much. So in one of my visits, my mother came to me to ask. She said, okay, we're laying the base of the kiln, and it has to be really exactly rectangular in order for the fluid dynamics and everything to work out. The problem is that she had a straight edge, she had a ruler, measuring tape. This thing is very, very large, like 12, 15 feet long. And yet she sort of didn't have a T-square because it broke at the time, and she couldn't go out to get one for various reasons. And she asked me if there's any way to determine if the sort of right angles really were right angles from just having a straight edge and a measuring tape. So that's sort of the colloquial version, right? She comes to me, and even though it has some math language mixed in there, like right angles, it's really just a problem. She's like, here's a problem, can you solve this? So I thought about it for a little bit, and I'm like, okay, jot down a thing. I want to know, here's this sort of rectangle we think, right? This rectangular structure we're trying to build. And we want to determine, okay, how do we know if the angles are sort of square, right? How do we know that they are actually 90 degrees without having some sort of right angle measuring tool? So I'm looking at this thing, right? I literally took out a piece of paper, jotted this stuff down, looked at it, and I was like, okay, I have these 4 angles. What do I do? Well, the sort of classic thing to do in geometry, take your rectangle and start looking at the angles by measuring the lengths, right? That's the information we have. And then cut that thing in half, right? Make this thing a bunch of triangles, because in practice, right, with really any shape, you sort of reduce it to triangles a lot of the time and see what you can do. But when I was looking at this, you're like, oh, okay, well, that's a right triangle, right? Or at least I hope it is, because the whole question is whether or not that thing is a 90-degree angle. But all I know are the sides. But we have a thing to relate these things, right? Specifically, our good friend, the Pythagorean theorem, right? That classic example of when would you ever use this? So the Pythagorean theorem says, okay, if you have a triangle, that triangle is a right triangle if and only if it sort of has that property, right? A squared plus b squared equals c squared. Usually we do that to figure out one of the side lengths, but we can go the other direction. We can say, okay, if a squared plus b squared equals c squared, that tells me then that it must have been a right triangle. So in particular, that angle, right, this sort of angle down here that we're not sure about, that thing is actually going to be a 90-degree angle, which is what we wanted, right? And in fact, that one measurement, right, that one diagonal C value gives me the bottom and the top, right? The bottom right, top left in this case, angles. I want all 4 angles, but if I go back to my original rectangle, I can just take the other diagonal and do the same thing, right? Check the bottom left and the top right. So this is exactly what I told my mother. I was like, okay, what are the lengths supposed to be? Use the Pythagorean theorem to calculate what the C length should be, right? What the diagonal is, and say, okay, well, it's a right triangle if when you measure sort of corner to corner diagonally, you get exactly this length. And if it's a right triangle, that means that you have a 90-degree angle. So just measure both diagonals, make sure that the right number as well as the lengths, as long as everything's straight, you're good to go, okay? Now, this example is not intended to be like, see, we do use Pythagorean theorem, because what are the odds that you're going to run into a kiln building problem in your own life, right? The point of this is that if I sort of just get the problem and I'm like, how could I do this? It's very easy to be like, I don't have enough information or I don't know. The idea is to be like, okay, translate it from the English thing, like I have this problem and I need to know whether or not these angles are 90 degrees, to, okay, how could I tell if it's 90 degrees? What things do I know about? Well, I know sort of a bunch of geometry, a bunch of trigonometry. Which of those things have to do with 90 degrees? Pythagorean theorem is like the go-to thing. Is there a way I could apply that somehow here, right? So it's more about sort of understanding that when you learn this material, it's not necessarily because you're going to use it this way, right? It's that you want to have it in the back of your mind so that when a problem comes up, you can sort of do this process of, okay, translate it into something sort of manageable, mathematical, sort of draw the picture, as it were, so you can see what's going on, and see if you can then sort of bring your tools to bear. What tools are sort of applicable here? What might get me where I want to go? That's the process of mathematical reasoning. Okay? So what we do? Well, we talked about mathematical reasoning sort of at a high level, this idea that, you sort of get these colloquial problems, these sort of just casual language problems, shall we say, that maybe don't have a lot of precision to them. And then you want to sort of filter that down to something precise that you can sort of write out, not necessarily as a formula, but, as a picture or something that you can sort of really get real information on. You can sort of very closely analyze each of the pieces and then see what tools you have that might work. And that process of sort of converting it to something that you can really work with and then working through it with whatever tools you have that are sort of available, that's what mathematical reasoning is. Okay, so that is that.